overtime? Oh. I want to see two.
All right, let's try this again. So, on number 31, yes, let's try to focus now. All right, on number 31, they gave us a triangle and they gave us lots of different angles are marked as congruent. They want to know what is the value of x. Well, first thing that we know for sure, guys, in a triangle, all the angles add up to what? 180. So in both of these triangles, we could easily say that, hey, this one has to add up to 180, and this one has to add up to 180. Now, there are multiple ways to do this problem. I think the shortest and easiest way is over here, we have an equilateral triangle, right? Let me see the equilateral triangle. All right, we know it's equilateral because all these angles are congruent, so it's actually equal angular, which also makes it equilateral. But long story short, 180 degrees, if you divide it by 3, all 3 of these have to equal what? Well, but what do they actually equal? So 180 divided by 3 is 60. So all 3 of these are 60 degrees. Now, the next thing that you could do, and again, like I said, there's many different ways to go from this point. These 2 angles are congruent. They are also this angle, and then again, these 2 form a special relationship. This is an exterior angle with these 2 remote interior angles or 2 non-adjacent interior angles. So the sum of these 2 has to equal that exterior angle for this other triangle. Since they're both the same, we can take that 60 and divide it in half, and we get 30 for, oops, side, went too far. I lied. Don't highlight that yet. So I get 30 for each of these angles. Huh? Yeah. Sorry, I went a little too far. Oh. I just said I went too far. So 30 is each of those angles. Now that we know each of those angles, the question was asking for the value of x. So I can take the 30 and say equal. So add 18, that's 48. Divide by 8.
It's 6.
And it's 6. How do you know the answer was 8?
So I did all my work.
You did all your work?
I did. The only one I didn't do was 36. I didn't help with, but I did that.
All right. So on there we have, again, other ways that we could have went. That's just one possibility. Now on 32, a triangle has 2 sides measuring 8.5 centimeters and 15 centimeters. What's the greatest whole number length possible for the third side? Explain. So on here, since we know these 2 measurements, in order to figure out that third side, what are we going to do?
You have to divide? Or no?
No, not really. I have 2 of the 3 sides.
I don't know what you have to. That's what I did do.
So this was in the section that we just got done with. Over. If we know 2 sides of the triangle, to figure out the range of possibilities for the third side, we had to find the sum and the difference, right? They want the greatest whole number. So if we add those together, add them, and we get 23.5. Now, that's the top end of our range. They wanted the greatest whole number. So what's the greatest whole number? Do I go up? No, that's the top end of the range. I'm not rounding up. Because again, the range is from, if I had subtracted these, I've got bottom end, this is the top end, so it's the first number below that, so 23. So looking at my answer choices, this one's out and this one's out because they rounded up to 24. Now, as far as explanations go, read through these 2 explanations and see which one actually makes sense. So it says 23, the third side length must be greater than. So does it have to be greater than that?
Wait, so what the answer we gave?
Does it have to be greater than that?
No.
No, it has to be less than. So go down to C. The third side length must be less than those two added together. The C has the correct explanation. Again, in order to find the range of values that works, add and subtract. So on this one, you just had to add them to find the highest number, and this is the greatest whole number. So 0.3 was the greatest whole number. All right, on 33, it says you construct a stage for a triangular mounting. Triangle ABC. Side or segment AB is about 28 feet long. BC is about 26 feet long, and AC is about 35 feet long. Order the angles of ABC in the order from smallest to largest. Now, ladies and gents, what would be helpful here? What don't we have that would be very helpful?
We don't have the order. We don't have the order, like specifically.
Okay. But what's missing from this that would be very helpful? What's the first thing you should use in a problem? Or draw any problem if it's not there?
We don't have a diagram.
We don't have a diagram. Wouldn't it be nice to have a diagram to look at? So, draw a triangle. Label it. A, B, C. Label all the parts they gave us. All right, this side's 28. Then we have BC is 26. And then AC is 35. They want us to put them in order from smallest to largest, the angles. So what's the smallest angle? 26 is the smallest angle?
No, it's AC. It's
A. Right? 26 is the smallest side, so the smallest angle has to be across from it. So angle A is the smallest. What's the next smallest angle? What was it? C. And then the longest or the biggest angle is B, because it's across from the longest side. Get smallest angle across the smallest side. Biggest angle across the biggest side. All right.
Wait, next. Sorry.
All right, 34. Again, there's no diagram there. The angle measures of ABC are 35, 42, and 103. List the sides of the triangle in order from longest to shortest. Again, first thing you should do, draw a diagram. A,
Oh, I got this one.
C. So then, if we label this, A was 35.
There's like this in my paper.
Then B was 42. And finally, C was 103.
I didn't work it.
So, which one is the longest side? AB. Longest. It said longest to shortest this time. So they switched it up on us. So AB is across from the biggest angle. Again, is my finger drawn to scale? No, it doesn't have to be. But I have a diagram. I label it. So now we can use those measurements to help us out. So the 103 is the biggest angle. Across from that is segment AB. What's the next biggest side? AC. And then finally, the shortest side will be CB or BC. All right. Did I pass it back yet? It's over there on my desk. Any questions here before we move on? No? All right. Keep going then. Right, on 35, how does GJ compare to HJ? So again, this one and this one. Well, we have angles over here. These two sides are congruent. This side is shared. They're congruent. So we have two angles, two sides and an included angle. Well, the sides are the same, but the angle's different. So that means that the side across from the bigger one has to be bigger than the one across from the smaller angle. So, which one's bigger out of these two pieces? Is it GJ or HJ? HJ. HJ is bigger because 56 is bigger. So since that one is the bigger angle, the side across from it is the bigger side. So HJ will will be bigger than GJ. Here they have it listed with a less than sign, so GJ is less than HJ.
Did you really just say that?
Sure. So again, this goes back to our idea of the hinge theorem from our last chapter. We have a triangle where we have these two sides are marked as congruent. The side in the middle, they share, which Flex property says that it is congruent to itself. So we have two sides that are congruent in both triangles. Since the sides are congruent and we're getting the angle in between those two congruent sides, we can match up a relationship between that angle and the side across from it. The one across from the bigger angle is going to be the bigger of the two sides. The one across from the smaller one is going to be the smaller of the two sides. So since 56 is bigger, the side across from it is bigger than the other.
That makes sense.
All right, moving on. 36. If BD, FBD are midpoints of EC, AC, and AE, respectively, then, so they're telling us these 3 points are midpoints. I'm going to go ahead and label it so that we can tell they are midpoints. So now, they asked us several questions. First, what point is G called? Well, what are these lines? What are these lines here? They're going from vertex to opposite midpoint. They are called
No, they're not congruent, but they're
medians. Right, they're medians. Where do the medians meet? Where do medians meet?
in the middle.
At a point called the
So it's like mid.
centroid.
Oh, it's right.
All right, this is from our last chapter. All right, so what point is G called? G is the centroid. B asked, true or false? G is the center of gravity.
Yes.
Yes, again, the centroid is the center of gravity, so that was true. Again, part A, this is our answer for part A. And I'm writing it over here as well. So it's there. All right, for C, we have AG is 10. If that piece is 10, what is FG? 5, yeah. Again, this is 2/3 the overall length, this is 1/3 the overall length. All right. DG is 6. What is DC? So GC would be 12. The whole thing would be, so 6 plus 12 is 18. All right, this is 1/3 the overall length. And then EB, so this is the whole thing, is 21. What's BG? So the small piece is 1/3 the overall length. So the whole thing is 21. What's a third of 21?
The third of 21 would be
21 divided by 3
is 7.
7.
Yeah, I was right.
Okay.
I was
All right. Questions there?
Was this due this paper was due last night, right? Or is it due today?
It was. This one, I did say I was going to extend it. So.
It says tomorrow that 51 through 76 is due,
Yes.
right?
Yeah.
I already turned this in, but two of them were answered. Yes,
Turn again. I'll move the date over to today. I'll move the date to today. All right.
What date was today?
The one up through 50, right?
That was your plan.
I'll move it to today because I said I was going to extend it, so I'll move it to today. The ones that are currently going over, even though I shouldn't, I'm going to move it to today. So get turned in. All right. Let's go over some more. What time is this period end?
1, 2, 3,
108.
5. That's how I
Right on low on time. All right.
Sorry.
So can you come up? Oh, there you go, please.
It depends on what it helps with, because if it's unnecessary.
So you got some detail? Yes.
All right, let's see if we can at least get these four done. On 37, point N is the in-center of ABC. So again, it's the in-center. In-center means it's where all the what meets. So in-center is where the angle bisectors meet.
Don't worry, it's just green bricks, but I can.
So they told us ND, this piece here, is 4x plus 5, and NE is 8x minus 3. What is the length of NF? Well, if this is our in-center, it's also the center of our inscribed circle, so all three of those lines are the same length. So set those two equal that they gave us and solve. Subtract the 4x, we're left with 4x. Add 3, we have 8. Divide by 4, and x is 2. Now, we need to know the length of NF, which is going to be the same length as either of those other two pieces. So plug it back in. 4
4x plus 5.
times 2 plus 5. 4 times 2 is 8. 8 plus 5 is 13.
Answer is B.
All right. 38. Point D is the centroid. So it's telling us it is the centroid of the triangle. BD is 5x plus 2. DF is 3x. Find the value of x. Well, what do we know about this piece? You guys told me it was 108.
We've used a lot of brain power today, Mr. C. Jack. You said that they're losing brain?
108.
You won't tell them to their face.
Are you talking about what thing? Was the picture of the
It was like a whole schedule, like a real thing.
Like a real thing.
from the
That's how it spins that off.
Yeah.
Yeah.
Okay.
And then the 108, and then.
What do you take? Let me see what you have.
One of y'all see moving slow now.
All right.
Yes, it's both. That's trick question.
Anyway, on this one, so these two, again, this one is half that one, so I need to double this one to get that length. I'm going to take that 3x. I got to multiply it by 2 in order for it to equal that other length.
What do you want?
So 2 times 3 is 6. Bring the 5 over, subtract it.
Wait, was it plus or minus? Let's just read that. We did this.
Plus.
Different.
No?
I did it different.
It's different. Did you take this and divide by 2?
I mean, I still got.
Not gonna help it?
That works.
You not see what we're doing right now?
Wait, does that work? Hold on. You said BD is 2.
Oh, his dreads?
Yeah. Wow, that's really confusing.
Did I get the answer right though?
Yeah.
I just do it like a Walmart. Like, that's how it's taught.
You're talking about who?
This question.
I think he's a
My old math teacher.
Now, what if we not all you told us? Like, I thought about taking
Is it right, though?
nuts.
You got your answer too?
He's gonna be pissed. They gonna have to cut them all out and take a bath.
Okay.
He needs detox. I seen his scalp.
Alright, anyway,
Fucking
on 39. Find the coordinates of the circumcenter of ABC with vertices at these 3 points. So,
Hey,
this one, I would go to graphing first. Alright, so if we were to graph this, we have a point at 1, 0. We have a point at 7,
I don't know about his.
7, negative 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6.
Not easy to that. Oh, that way. Still far, right?
What? 0. And then we have a point All right, for this one,
But no, is there any more?
nope, not ready to pay them. Whoever made this exam. Most likely they would only give you a right triangle on the exams. Here they gave us a two triangle, so I figured our actual points would be way outside of this figure.
Right here? No.
It'll be somewhere over here. We'd have to do a lot of work to do that one. We'll come back to 39. All right, Bell's getting ready to ring. We'll stop here for right now.